All right, welcome back to part two of the second notes video of part three of the Unit 7 note packet. And so let's just continue our discussion here. So when I left you on the last video, we were making this circle right here. I'll erase that, but we were making that circle right there. And what we put was a center. We put a couple points on the outside. We added a angle to that center, so that's a central angle. We called it 110. We just made that up. It might be 110, it might not be 110. But then we talked about how central angle measures and the arc measures are the same, right? And we learned that in last part's note video. And so I wrote that down. Measure of arc JL is 110 degrees. Now we're getting close to the discussion about how even though we can talk about the degree measures of different arcs or the whole circles being 360, when we find length, like we did up here, perimeter, right, of the circle, we called that circumference. When we actually find the length of the circle, we get different numbers than the degree measures or 360, right? This length was 37.7, this one 50.3, this radius 6.4, this one 13. And so even though a circle always measures 360 degrees in total, if they're asking us about length, they're not asking us about degree measure. They're asking us about something else, right? And so we use formulas like the circumference to figure that out. And so that's where this discussion is moving. And so let's keep talking about arcs and their degree measures, because then when we talk about arc length, we'll see how to use those degree measures, but convert it into a length instead of a degree measure. So here we go. So again, we are working with this circle we just drew. We drew a central angle that equals the arc measure. And then if we want to know like what the other arc is, the big one, for instance, this side of the circle, well, we know the whole circle is just 360 degrees. And so the rest of the circle, which is the measure of arc JNL, so major arc, three letters, is just going to be 360 minus 110, which is what, 250 degrees, right? And so that's what an arc is. It's part of the circle, and so it has some sort of degree measure anywhere between 0 and 360, right? Because a circle is 360 degrees total. So part of it is somewhere in between 0 and 360. Now, let's talk about arc length, because again, arc length is different than degrees. And so here's how this works. Let's say we have this circle over here, and we've got a center, and this creates a central angle. And we call these points A and B. And so let's say we want to figure out the length of arc AB. The length of arc AB. Well, first of all, remember length means like distance, right? So we're finding out how long that is, and that does not mean degree measure. Distance, not degree measure. And so that's one of the toughest parts about this learning target is differentiating those two. Are they asking me for a degree measure or are they asking me for a length or distance? And if you see the word length, that's when they are asking you for a distance. And so here's how we would find the length of arc AB. So the length of arc AB is found by this formula. And basically, it's the circumference formula again. So pi times diameter, or pi 2 times pi times radius, but we just need it, that circumference gives you the distance around the whole circle. We need to just do a distance around part of a circle, around a fraction of the circle. And so here's what we do. We figure out this is a certain degree measure, and this is that same degree measure. And so we're going to do whatever that degree measure is divided by 360. And then we will times that by pi times our diameter. And so this piece is our circumference. And then this piece is just a fraction. And so this is us taking our circumference, but reducing it to a specific fraction that we want it to cover, right? And that fraction is just this x piece out of the entire 360. Now, that's a lot of discussion. It probably made no sense. So let's practice it a little bit. So if we want to find the length AB, and we're going to assume that was a B, and so we're trying to find the length of this arc here. here's what we would do. Remember, recognize we'll have an angle here. This arc will have the same measure because central angles and arc measures are the same. And so that's like our x degree part. And so in this formula, remember, I'll write it up here. It is whatever our central angle is divided by 360 times pi times our diameter. And so here we go. Recognize our radius equals 12. So our diameter is twice as big as that. So our diameter is 24. And all we want to do is plug it into that formula up there. So our x degree measure is always our central angle. So we're going to do 45 divided by 360. And we'll times that by pi and then times our diameter. So 24. And so I know it says leave answers in terms of pi. Let's cross that out and let's say nearest tenth. And so what we have to do is just type this into our calculator. Now I want to walk you through that because I want to talk about this fraction out here, the 45 divided by 360 part. So when we type that into our calculator, let's make sure we put that in parentheses. So when we do the 45 divided by 360, let me see if I can get it over to the side. There we go. When we do 45 divided by 360, let's put the fraction in parentheses. We'll start with parentheses. We'll do 45 divided by 360. We'll close the parentheses, and then we'll do times pi times 24. And that'll be our answer. So we hit enter. It says 9.4. And so we say equals 9.4. Units are centimeters. And there we go, 9.4 centimeters. So again, it's just a question of finding the information you need and plugging into the formula. Remember, the formula is the circumference formula. It's pi times diameter still, but then we just reduce it to whatever fraction of the circle we want. And so in this one, AB is right here. AB is going to be 120 degrees. Our R is 6, which means our diameter is 12 because it's twice as big. And so our formula this time is 120 divided by 360, and then times pi, and then times our diameter, so 12. And we just got to go type that into our calculator. Remember to put the fraction in parentheses. And so I'll do that again with you. I'll clear the screen so it's easier to see. So parentheses, 120 divided by 360, close parentheses, times pi times 12. Hit enter. There it is. We'll round up to 12.6. 12.6 feet. All right, one more. This time, I think it's pretty clear. We have a radius equal to 7. Diameter is twice as big, so that'll be 14. We don't have an x degree measure though, right? We want to find A to B, so that's here. But we don't know that number except for we see this box, right? And so that's got to be 90 degrees. And so we'll do 90 degrees divided by 360, and then times pi, and then times our diameter, so 14. Typing that into our calculator, I think you can do that at this point, and that'll roughly be 11.0 inches is our unit. All right. Now, let's continue this. 3 more problems and we're done. Problem 2 and problem 3 down in this example, we are going to need to work backwards. And so that'll be interesting in just a sec. But let's go through problem number 1 here. We're doing the same thing. We're finding the length of AB. Now, notice they don't have any numbers on our radius or our diameter up here, but they do tell us right here. And anytime you see the D, we're going to assume that means diameter. So diameter is 20. So that's perfect. We don't have to worry about that. We already have our diameter. And then A to B, right, is this angle right here, the one that intercepts at A and B. And so our x degree measure is 135. So we'll do 135 divided by 360 times pi times our diameter, which is 20. And so we'll type that into our calculator. I'll actually do it with you this time, just one more reminder. So we'll pull up the calculator, parentheses for our degrees, so 135 divided by 360, close the parentheses, and then times pi times 20, and we get 23.6. 23.6. and these are centimeters. So that's our answer. Now, how can we do this? By working backwards. And so what you need to be able to read in this picture is this. We want to find circumference. And this right here is our length. This is our arc length. And so remember, the formula is going to be arc length equals x over 360 times pi times diameter. And so if we want to find circumference, let's find diameter first, and then we'll plug it into the circumference formula, right? And so basically, here's what we have. We know our arc length. So we can set this whole big equation equal to 15 in this problem. And we know our x degree measure, right? It's 60. And so this will equal 60 divided by 360. And then it'll be times pi. And we don't know our radius or our diameter. No numbers are here. And so that's why we have to work backwards to solve for it. So diameter is still just diameter. What we're working to do is get the d by itself. And so what we need to do is let's figure out what 60 divided by 360 times pi equals. That'll give us a number for this piece. And then we just have to divide both sides by that. Here's what I mean by that. What we want to do right now is just type what I've circled into our calculator. And so I'm going to grab our calculator out, and I am just going to type 60 divided by 360 in parentheses again. And then we'll times it by pi. And that equals 0.52. Let's just call it 0.52. And so I'm going to come back here, and I haven't done anything with the 15 yet, so it's still 15. But then remember, what we've circled is what we typed into our calculator, so that's just 0.52, and then we still have the diameter there. And by doing that, it makes it a little bit more clear. Now we want diameter by itself, right? So we just divide both sides by 0.52. Because when we divide by that, it cancels off of that side, and it's going to equal what our diameter is, and we just want to type in 15 divided by 0.52. So let's talk calculator again. We will put 15 here, and we say divided by 0.52. So I'm going to hit divide, and then I'm going to hit this up arrow up here and highlight my 0.52, and when I hit enter, it just puts it into the next, what I want to do. So I'm doing 15 divided by that number right now. When I hit enter again, it'll tell me what it is, and that answer is 28.6. 28.6. And that is my diameter. Now remember, I don't want my diameter. I want circumference. And so once I get my diameter, circumference equals pi times diameter. And so my circumference will be pi times 28.6. So I'll go back to my calculator, and I'll take my 28.6, and it's already loaded there, so I'll just hit times, and then I'll times by pi, and we get 90 for their circumference, 90. And that is 90 inches in this problem, 90 inches. All right, one problem left and not much time. Same deal here. This is a 90-degree angle, obviously, and now we just want to find radius, and this is our length. And so we'll say 18 pi equals 90 divided by 360 times pi times our diameter. Remember, we want to find our diameter again, and then we'll divide it by 2 to get our radius. And so let's figure out what this equals here, right? Everything in front of our diameter. And so we'll take our calculator and we'll type in 90 divided by 360, close your parentheses, times pi, and that equals 0.785. So we'll say 18 pi equals 0.785 times diameter. We'll divide both sides by 0.785. Cancel that out. So that'll give us our diameter. And we just want to type that into our calculator.